Good day, students. Today we continue our lectures on physics. Now we talk about mechanical oscillations, mechanical waves. Periodicity is peculiar to many processes taking place in biological systems. It may be observed in functional activity of the heart, lungs, stomach. Some processes in living organisms may be considered as oscillatory, oscillation of vascular walls at propagation of pulse waves, oscillation of blood pressure in vessels, air volume in lungs, oscillation of tympanic membranes, vocal ligaments, biopotential values in different points of human body. Free undamped oscillations. Simple harmonic motion. Free undamped oscillations are those that appear in a system due to the action of interval forces only as a result of some initial deviation of the system from the state of stable equilibrium. Let's consider a spring pendulum. Look at the picture. When a material point of mass m shift on distance x, it's a distance, relative to equilibrium position, it starts to be influenced by elastic force resulting from spring deformation. This force is directed oppositely to the displacement. Right Hooke's law, this way, where K is a coefficient of elasticity. In accordance with Newton's law, this force will accelerate the material point. And we can write Newton's second law in this form. Where A is an acceleration and A is equal x with two strokes, and strokes is a time derivative. And we can write down, use force elasticity, this equation. Divided this equation by mass, and the ratio K divided by M be denoted by square of some value omega 0. Look here. And we can write down a differential equation of undamped oscillation here. We could say expression 4. And where this ratio K divided by M is omega 0 in square. The solution for equation 4 will look like this form with a cos, or this form with a sin. And then a characteristic of undamped harmonic oscillations. And the first characteristic is A. A is the amplitude, and T, it's a big T, is a period. F is a linear frequency, and V is the velocity of speed, and omega is a cyclic or circular angular frequency, and phi is a phase, and phi 0 is the initial phase, and E is the energy. The formula of frequency is F equal N divided by T. N is the number of complete or full oscillations. T is the time of complete oscillations. T, it's a big T, is the formula of the period. And we can write down the period in two ways. First, it's the time divided by N. N is a number of complete oscillations, and 1 divided by F. It's a frequency, linear frequency. The formula of circular frequency is omega 0 2 pi F, or we can write down another way, omega 0 equal 2 pi divided by period. And the formula of velocity is velocity is a first derivative of coordinate or displacement. X with a stroke is equal. This expression use a cos, or we can write down this expression with a sin. The formula of acceleration. The acceleration is x with the two strokes. And phi is the phase undamped harmonic oscillations. This initial phase, look at here. The expression in a bracket, the phase is a full phase. The formula of the total energy of harmonic oscillation of oscillator is the sum of its kinetic energy and the potential energy. And we can write down this expression here, where K equal M product by omega 0 in square. And the total energy this expression. Then free damped harmonic oscillation. Assume that the friction or resistance exists in the considered system where the force of friction is proportional to speed. Where R is the coefficient of friction, or we can say resistance. V is the velocity. Right, in this case, the equation of motion and this second Newton's law. Here. And we can write down some of the force, elasticity, and friction. And can write down a differential equation of damped harmonic oscillation. It's number 5. Where this ratio k divided by m is omega 0 in square, and r divided by m is 2 beta. Different equation of damped harmonic oscillation we can rewrite in the form expression 6. The solution for equation 6 will look like expression 7. This expression uses sin. And omega is a frequency, is a circular frequency. Then look at this picture, the graph of damped oscillations, where A0 is the oscillation amplitude in the initial moment of the time. It's here. The oscillation amplitude decreases to the exponential law. Exponential law. And this solution for equation 6, look at here, and this is a period. Characteristic of damped oscillation. And the first characteristic is a period of damped oscillation. We can write down this form, and the cycle frequency of damped oscillation is this form. And third characteristic is a logarithmic decrement of damping is delta. Delta equal is a logarithm of ratio of amplitude. This amplitude at time t and some time plus period, or the second form of logarithmic decrement is beta product period. And we can see delta and this amplitude and this, and we can write down this amplitude with amplitude 0. It's the initial time, and we get this expression beta period. First, oscillations. Let us assume that a material point with a mass m, in addition to elastic force and the force of frictions, is influenced by external driving force which change in accordance with periodical law. With the C, where F0 is the amplitude, omega is a cyclic frequency of driving force. In this case, the equation of motion will look like, and this Newton's second law, and now we can see some of three forces. And denoting k divided by m is omega 0 in square, and R divided by M is 2 beta, and F0 divided by M is F0, small f. And then we can get a different equation of forces oscillation. This is question 8. And the general solution for differential equation will be, we can write down in this form, where A is the amplitude of forced oscillation, this form, and alpha is a phase. And then we can talk about resonance. The phenomena of a sharp increase of forced oscillation of a system when the cycle frequency of the driving force approaches the value omega. Resonance is called a resonance. Resonance phenomena is observed at the frequency omega 0 is equal to omega resonance, whether the amplitude of forced oscillation A reaches a maximum value. And we can see this omega resonance. The maximum value A resonance of the amplitude correspond to the resonance cycle frequency. We can write down this form. Infrasonic vibrations of great amplitude may be hazardous for human beings, as some processes in human organism take place within the slot of infrasonic frequencies. For example, alpha rhythm of the brain have frequency slot 9 or 13 Hz. And therefore, action of infrasonic waves may cause harmful resonance in human brain. At the nuclear level, the process called nuclear magnetic resonance uses resonant behavior of photons to probe the structure of matter and to produce image used in medical diagnosis. Magnetic resonance imaging of a human brain involves the resonant absorption of energy by photons in the brain tissue. And talk about outer oscillations. Systems which automatically regulate supply of energy from external source are called outer oscillating, and periodical processes which occur in them are called outer oscillations. Amplitude and the frequency of outer oscillations depend on the properties of the system. The scheme of outer oscillation system consists of 4 compulsory elements is represented in this figure. Example of the outer oscillatory system are following. The first, clock. Or pendulum oscillating system. Lifted balance weight of spring is a source of energy. Echo regulator of energy entry from the source into oscillating system connected with the oscillating system by feedback. Generator of the electromagnetic oscillation. Heart, lungs are biological outer oscillatory systems. Outer oscillations may be of different form. It may be oscillations close to harmonic, pendulum clock, oscillation in LC generators, or pulse oscillation of different forms, rectangular, exponential, or solar. Vibration therapy has been proposed as an option to improve physical performance and reduce the negative effects of aging on bone, muscles, and tendons. Several discrepancies exist in the type of application, frequency, and magnitude. This difference reflects on the contradictory clinical results in literature. And then talk about mechanical waves. The process of propagation of oscillatory movement in an elastic medium is called mechanical wave. The type of mechanical waves. There are two types of wave, transverse and longitudinal. Transverse waves. A transverse wave is a traveling wave in which the particle of the distributed medium move perpendicular to the direction of wave motion. Transverse wave are like wave along a string or a rope. Look at this picture. The energy is transferring from left to right, but the particles of the rope are only moving up or down. Look here, up, or down. In transverse waves, medium's particles perform oscillation in direction perpendicular to the direction of propagation. Transverse waves can be produced in solids and on a surface of liquids. In the transverse waves, all the particles of medium execute simple harmonic oscillations about their mean position. The position of maximal displacement in the upward direction is called the crest, and the position of maximum displacement in a downward direction is called the throw. The distance between two successive crests or throws is called the wavelength of the transverse wave. Longitudinal or compressional waves. A longitudinal wave is a traveling wave in which the particle of the distributed medium moves parallel to the direction of wave motion. Look at here, this direction of propagation and this displacement of particle. In this type of wave, particles are oscillating along the direction of wave propagation. Longitudinal waves can propagate through solids, fluid, and gases. In the longitudinal wave, all the particles of medium execute also simple harmonic oscillation about their main position. Longitudinal wave alternation of the region of refraction and compression of the medium where this wave propagates. The distance between two successive compressions or two successive refractions is called wavelength of the longitudinal wave. A spring like a slinky can be used to demonstrate a longitudinal wave. Here the particle oscillates about fixed points from left to right, and the energy is transferred from left to right. Sound waves are longitudinal waves. and the characteristic of mechanical waves. The first. The first is the amplitude, is the absolute value of the maximum displacement of this quantity from its equilibrium value. Unit of amplitude in the C system is a meter. And the period is the time required for one full oscillation. Unit of period in the C system is a second. Frequency is a number of full oscillation by particles of medium per unit time. There is an inverse relation between a wave's frequency and its period. Unit of frequency in C system is the hertz. Phase of oscillating particles denote its position and direction of motion at any moment of time. Unit of phase in C system is the radian.
По поводу вируса на компьютере.
У меня лекция идет.
Через сколько?
В 13. Velocity of a wave is a speed which a wavefront travels in a medium. Unit of speed in the C system is a meter per second. Wavefront is a surface which the wave has reached in some time point. In the case wavefront in a plane, x is a constant. That is why the wave is called plane. A wave surface from is determined by configuration of oscillation source and medium properties. In isotropic medium is spherical waves which has sphere as surface it propagates from the point source. Wavelength is the shortest distance between the points of a wave whose oscillation phase differ by 2 pi. Unit of wavelength is a meter. Energy flow is the quantity of energy transferred by the wave through surface S per unit time. Wave intensity is the energy flow transferred by the wave through a unit area of the surface perpendicular to the propagation. S is the area. Is a I. It's here. Is a watt divided by meter and square. And volume density of energy. So volume density of energy. These units in a C system is a joule divided by meter. And then talk about a wave equation. The displacement of particles caused by the plane wave can be described by the general equation of wave motion. And we can write down S equal F of x and t. Assumes that a wave process is propagated in positive direction of x or x and the source of oscillation in the plane perpendicular to the propagation direction and oscillates according to the law. And we can write down S is equal A cos omega t. And let V be the speed of propagation of wave process in medium. In the time interval is a tau, the ratio of R divided by V. The wave process will reach point B. which is at the distance r from the source of oscillation and will cause oscillations of the point in time interval tau according to the law. But here, t minus tau. And wave equation we can write down in this way, where wavelength is speed product to period. And the Doppler effect. The Doppler effect is a change in a frequency and the wavelength of a wave when the observed and the source of the wave move relative to each other. Let us consider a source of waves with a constant frequency and amplitude. The observer and the source are fixed, and wavelengths equal to product velocity or speed and period, or velocity divided by f. The observer moves to the source. The source is fixed, and we can write down f with a stroke this form. We can two situations in this way. F stroke more than f, the observer moves toward the source, and f stroke with stroke less f, the observer moves away from the source. Third, if the source of waves follow a wave, then the wavelength is smaller. And look here. And we can write down f with the two strokes. This expression, and we can have two situations. F with the two stroke more than f, the source moves toward the observer. And second, f with the two strokes less than f, the source moves away from the observer. And the last, as a general equation for the Doppler effect is f with three strokes. Here f is a frequency of wave emitted by the source, and f with three strokes is a frequency of wave perceived by the observer. V is the velocity of wave in the immovable medium. V0 and Vs are the speeds of the observer and the source of waves. The upper symbol plus and minus concern the case when relative motion between the source and observer is moving them to meet. The down symbols concern the case when they are moving away from each other. The change of frequency of the wave due to Doppler effect is named the Doppler shift. This phenomenon is used to measure the speed of various moving bodies, including the erythrocytes in the blood vessels. And talk about acoustics and sound waves. The nature of sound. Acoustics is a field of physics. The subject matter of acoustics is the study of physical nature of sound, mechanism of its generation, propagation, and practical application. Sound is a medical is mechanical waves with a frequency in the interval from 16 Hz to 20 kilohertz, which propagate in elastic medium. The particles of the medium do not travel forward. They only oscillate about their mean position in the direction of wave propagation. But the energy of the sound is transmitted from one particles of medium to another. The sound is transferred by the sequence of compression and refractions. The wavelength is the average distance from the compressions to the next or from one reflection to the next. And acoustic scales. Type of sound and frequency. Look at this table. And we can see infrasound and audible sound, ultrasonic and hypersound. Ultrasound and hypersound. All sound fall into tones or musical sound, noises and sonic booms, tones. Tones are those resulting from oscillation of a source with constant amplitude and frequency. Pure tones is a harmonic oscillation of source. Frequency is a main characteristic of a pure tone. For example, sound of tuning fork. Complex tones is resulting from non-harmonic oscillation. A complex tone can be split into simple tones. For example, human voice, sounds of musical instruments. Complex tone may be decomposed into pure tones. A pure tones included in the complex one and which has two lowest frequency, F0 is called fundamental or main. Pure tone included in the complex tone and those which have frequency divisible by frequency of a fundamental tone. Complex tone has a line acoustic spectrum. It's this A. Noise is a complex aperiodic sound with a continuous spectrum. Noises may differ by spectrums. For example, low frequency noises and high frequency noises have different amplitudes in corresponding zones of spectrum. This picture B. Its amplitude and period of oscillation change irregularly. The examples of noise are rustles, the constants of human voice, claps, etc. The use of sound in medicine. Audiometry is a method for measurement of hearing acuity. The individual curves of a patient's hearing threshold and different frequencies is determined by means of audiometer. The respective curves is called an audiogram. Comparing a patient's audiogram with the normal one makes it possible to diagnose ear disease. The audiometer is a sound generator with telephones which allow independent control of output signal frequency and intensity. Auscultation is the act of listening to sounds arising within organs as an aid to diagnosis and treatment. One uses a stethoscope and a phonendoscope. Percussion is an act or a technique of tapping the surface of a body part to learn the condition of the part's balance by the resulting sound. Percussion sounds are extracted by tapping with either of a hammer on a special plate called a pleximeter, or simply by the finger of one hand and the phalanx of the other hand applied to the patient's body. Phonocardiography is the method consists in graphical registration of heart sound and noises with their subsequent clinical interpretation. The method of phonocardiography is used to diagnose heart functioning. Phonocardiography is resulting by means of a phonocardiograph. Ultrasonic source features of distribution of ultrasonic waves. Ultrasound is called sound oscillations, which frequency borrows the range from 20 kilohertz up to 10 hertz. The top limit is accepted completely conditionally from such resonance that the length of wave is a substance and the tissue for such frequency pair is commensurable with the intermolecular distance in view of the speed of distribution of ultrasound in the water and the tissue is identical. The greatest distribution both in techniques and in medical practice, piezoelectric radiators of ultrasound have received. As a piezoelectric radiator use crystal of quartz or the synthetic ceramic lead zirconate titanate. Piezo effect is called phenomena of occurrence on surfaces of the mentioned crystal plates of opposite or marked change under action of mechanical deformation. After removal of deformation, charges disappear. There is also inverse piezo effect, which has found application and in medical practice for reception of high-frequency ultrasound. If on several sides of surface of plate of the piezo element to submit alternating voltage from a generator, the quartz plate will come in fluctuation in a step of alternating voltage of the generator. The amplitude of oscillation will be maximal when on frequency of quartz plates are near zero, coincide with the frequency of generated Vg. There will be resonance. The detector of ultrasound can be created on the basis of direct piezoelectric effects. This under influence of ultrasound wave, there is a deformation of a crystal that results in occurrence of alternating voltage, which can be measured or fixed on the screen of an electronic oscillograph after its preliminary amplification. A piezoelectric transducer can operate as an ultrasound generator and ultrasound detector. A typical transducer used in medical application is shown in this figure. The ultrasound we can get with the help of the devices based on the phenomena of magnetostrixia. Magnetostrixia is a phenomenon which will consist in change of length of the ferromagnetic core placed in a high-frequency magnetic field, and the faces of this core with radiate low-frequency ultrasound. Except for the specific source of ultrasound, the mechanical source in which mechanical energy will be transformed to energy of ultrasound oscillations. Ultrasound mechanical waves with a frequency from 20 kilohertz to 10 in 9 hertz. Ultrasound is generated by using such physical phenomena as the inverse piezoelectric effect and the magnetostriction. Piezoelectric effect was discovered by Pierre Curie in 1980. The essence of the inverse piezo effect is that piezoelectrics are subject to strain when placed in an electric field. Therefore, placing a piezoelectric crystal in an alternating electric field of ultrasound frequency make the crystal surface oscillate with this frequency and execute ultrasound waves in the environment. Magnetostriction is a changing of dimensions of ferrites in an alternating magnetic field. Placing ferrites into an alternating magnetic field of ultrasound frequency causes oscillation of the ferrite surface with the frequency excitation of ultrasound wave in the environment. Application of ultrasound in medicine. The most widespread application of ultrasound is in diagnostics. Such methods are called ultrasonographic detection. Ultrasonographic detection methods are based on reflection of ultrasound waves from external and internal surfaces of different human organs. It's possible a shortwave ultrasound cannot turn around obstacle with a size more than wavelengths. Party reflect from boundaries of medium information regarding the internal organs. Delta is a linear dimensions of the obstacles. If delta comparable to lambda is a wavelength of ultrasound, this is called the phenomenon of diffraction. Diffraction is a rounding of the wave barriers. If delta more than wavelength, then there is the shadow of ultrasound reflection and absorption of ultrasonic wave. Three type of scanning are common in the ultrasound diagnostics. First, A scan, amplitude. A scans can be used in order to measure distances. A transducer emits an ultrasonic pulse, and the time taken for the pulse to bounce off an object and the KMBX is graphed in order to determine how far away the object is. A scans only give one-dimensional information and therefore are not useful for imaging. Ultrasound beam is directed along a line through some parts of a body, for instance, through the brain. Ultrasound investigation of a brain is named echoencephalography. Ultrasound wave transverse the structures of brain and reflect from them. The mechanical waves are transformed into electric pulses of different amplitude on a display. The horizontal motion of the display beam is adjusted in time to represent both the original ultrasound pulse and its echo. The position of electric pulse on the display indicated the distance to the normal and pathological structures of brain and their location. B scan, B brightness. B scan can be used to take an image of a cross section through the body. The transducer is swept across the area, and the time taken for the pulses to return is used to determine distances, which are plotted as a series of dots on the image. B-scan will give two-dimensional information about the cross-section. This technique gives the possibility to observe two-dimensional picture of interior organs. It uses a movable ultrasound transducer. The electric voltage changes resulting from ultrasound pulses and their echo are added to the accelerating voltage in the electron gun of electronic tube. When the echo is present, a bright spot on the display appears. M-scan, M-motion. This method is useful in investigation of motion, for instance, the motion of the heart wall of the heart valves. Ultrasound wave is directed to the moving object and reflects from its surface. The horizontal motion of the display beam represents time intervals. The vertical deflection of the display beam reflects the amplitude of object movements. Ultrasound Doppler techniques. Echodopplerography. The use of the Doppler effect during ultrasound Doppler technique allows determining the blood flow velocity to examine the functioning of moving parts of organs. A high-frequency ultrasound beam is directed along the blood vessels. Ultrasound is reflected from blood cells that act as a moving source of ultrasound. They cause a Doppler shift. This is the frequency difference between emitted and reflected ultrasound that depends on the velocity of blood flow. The ultrasound received measures the amount of Doppler shift. Information arriving from the receiver is computed and I visualized to obtain a picture of blood vessels with the indication of blood flow rate. Before considering the therapeutic application of ultrasound, we will indicate the effect that appear when ultrasound wave pass through biological tissue. Micro vibrations at cellular and subcellular levels, destruction of macromolecules, reconstruction and damage of membranes leading to change in their permeability, heart release, destruction of cells and microorganism, formation of chemical highly active ions and free radicals. In nephrology, focused ultrasound is used for destruction of kidney stones in the urinary system and in the gallbladder. In stomatology, one for removal of dental calculus, drilling dental channels. The destructive action of ultrasound on microorganisms is used for sterilization of various medium. Cavitation is the appearance of microvoids in material medium under the action of pressure influence. In pharmacolytics, cavitation process caused by action of ultrasonic wave of great intensity are used for dispersion of hard and fluid material with the purpose of producing medium powders, emulsions, suspensions, and aerosols, as well as for homogenization of tissue when extracting biological activity substances. Therefore, and the human speech apparatus and its work, and the ear. You can read in a PDF file in a lecture. And now we talk about physical characteristic of sound. Physical and the first frequency and frequency spectrum. Velocity of sound describe how much distance such a wave travels in a given amount of time. The speed of sounds depends upon the compressibility, density, and the temperature of medium. For instance, in dry air, the speed of sound is 3033 meters per second. It's for temperature 0. And 3044 meters per second for temperature 20 degree of Celsius. In water, the speed of sound is 14.2 meters per second. Sound intensity is the amount of energy that is transported through a given area of the medium per unit of time. And intensity, it's watt divided by meter in square. The intensity range of hearing has two main characteristics. And the first, the threshold of hearing or threshold of audibility is a minimum intensity of sound that is audible at a given frequency. And the second, the threshold of pain or threshold of feeling is the intensity of sound wave which give rise to a painful, annoying sensation in ears. And then the level of intensity is determined by formula L is equal to logarithm of ratio I is a sound intensity divided by I0 is a sound intensity of hearing threshold. This formula of Weber-Fechner is, and we can see this law of Weber-Fechner's in laboratory work number 7. Subjective characteristic of auditory sensation. Loudness. The sensation of loudness corresponds roughly to the intensity level of sound, but the loudness of pure tones depends from their frequency. For example, the simple tone, which frequency is about 4,000 Hertz, seems louder than the tones with the same intensity level but other frequencies. Weber-Fechner's law may be deformed as follows. Irritation sensation, E, is a direct proportion to logarithm of intensity of the proper I. In other words, irritation intensity arises in geometric series that is by a factor of 100, 1000, etc. Then sensation of this irritation E increases in arithmetical progression, that is by a factor 2, 3, etc. Physiologist Weber and Fechner proved that the relation between the sound intensity and the level of its auditory sensation, loudness. The formula for loudness has the form Weber-Fechner law. But I thought about L, but this E and logarithm of ratio, and the K is a proportionality coefficient which depends on frequency and intensity. I is a sound intensity, I0 is the sound intensity of hearing threshold. And highness. Highness is a characteristic of sound that depends on its frequency. A low pitch tone has a smaller frequency, and a high pitch tone has the greater frequency. And timbre. Timbre is a characteristic of sound, but by which a man is able to differentiate between the sound coming from different musical instruments, even when the same note is played on all of them. This quality of sound depends upon the acoustic spectrum, the number of overtone, and the intensity. For now, that's all. Thank you for your attention, and I talk about your homework. Your homework, read a lecture in a PDF format, and take the test after lecture in 2 weeks. I will open the test for you tomorrow. And I will attach a PDF lecture, maybe tonight, or maybe tomorrow too. And your homework, read the lecture and take the short test, and that's all. Thank you for your attention. Goodbye. See you next lessons.